Now let us use the markup chain to define a function that will create a dictionary like structure. Now in this example we are going to predict the style of Ali Wong. So this is the comedian. If you remember, we have the data clean. If I go here and I'll print data clean for you, then you can see the comedian name and their transcript. So I want to predict and generate the text that is related to the style of Ali. So that is what I'm going to do. So for that I'm going to show you the transcript of Ali. Some of the transcripts, see here, this is some of the sentence of Ali. So this is just a transcript. So I'm going to use his style to generate the new text. So for that I'm going to use markup chain function, and this function will take the word in the corpus. It will take all the word and it will just return us a dictionary containing the word as a key, and the word that comes after it is a value. So for that we have to first of all split the word. We tokenize the word. That means this is where we tokenized our sentence or a document by the word. Then we create a default dictionary. Then here this will zip all the list of a word pairs in the key and value pair, something like this, what we studied over here. So some word, and in the document what comes after this word will be your value pair. So this way the dictionary will be created and we return the dictionary. For example, I run this function and now I'm going to just pass the Ali's text. You can see I have created the Ali's text here, only the transcript of the Ali. I'll take it and I'll send this to the markup chain. Now markup chain will just take the text that has been spoken by Ali, all of this text, like this text, or I can also show you all of his text right here. So all of this text, see here, all this text will be taken by this function in this text, and that will be tokenized. That means we will split all of these words one by one. Then we add it to the dictionary and we will find the next word that comes along that word and we append it as a list to our dictionary. Now if I run this line of a code, then you will see the dictionary has been created. So in the Ali's text, if the word is ladies, the word that comes after the ladies is the and, go, who, they, and who. So this is the key. Key here means the word, and the value, see here, the value after this represents the word that comes after this word ladies. And similarly we have this word and, see here with the word and inside this list you can see it is whole lot of big list. So it is, maybe it goes all the way down, okay, up to here. So this whole list of the word comes after right next of and. So basically after and he tells gentlemen. So ladies and after and he told gentlemen. So that is the way to create a markup chain dictionary. So we create a word in the key value pair where the word will be the key and the word that comes after this word will be the value. We can use this dictionary now to generate the text. Let's say I want to generate a text starting from the ladies. So I want to predict what might be generated after the ladies. So I'll say that I'm on the state ladies. Now from here I need to generate next word. Now to generate the next word we can go to the dictionary, and after ladies I can use one of these words. I can use and, I can use go, I can use who, I can use they, and who. Basically I will use and now, and I'll say I generated a new word and after and I need to generate again the new word. So after and I need to generate again new word, and here is the and. So after the word is and, you can use all of these, one of these randomly, one of these text from here. So let's say from all of these I'll take gentleman. Then I will just go over here. Then we will go over here, and the next word that I generate is gentleman. So after gentleman, again I have to predict something. Now you search again for the gentleman. So I will go over here, and you need to search where is the gentleman. So gentleman is right here. So if the word is gentleman, we have to use only the please. There is nothing else. After gentlemen, there is only the one word, which is please. So I can use this please now. So next word generated is please. So after please, I need to generate again the next word. So I go to the dictionary again, and after the please, I can use any of these words. I can use welcome, I can use no, I can use look. So I can use look maybe. So this way you generate the word, and you tell the algorithm how much word do you want to generate by yourself. Maybe how much sentence and how much word do you want to generate, and the algorithm will generate based on your preference. So that is how markup chain works. And this is the dictionary that we will be using to create a text generator now. So we are creating a function that takes the chain. What is the chain here? Chain will be nothing but this dictionary. The newly created dictionary will be passed to this chain, and the count 15 means how much word do you want to have. So basically I want a sentence of word 15. So this algorithm will generate me a sentence which will have a word count of 15, and I have given a dictionary. So now it will take a dictionary, and it will randomly choose a word from that dictionary. It will take one word from that dictionary. Let's say from the keys of a dictionary. It will take either ladies or and or something like that. It will take one word randomly because we have used the random choice here. And after we take that word, we are going to capitalize it because we want the first letter of the first sentence or the first word letter should be capitalized. So I capitalize it. I'll show you what this means. And now to generate the next word, we are only dependent upon the previous word, like this. In order to generate the word, let's say I want to generate the word after ladies, then we can only see the ladies. We are not caring about whatever we have above or beyond the ladies. So the next step that we need is only dependent of the previous single step. We also don't care the step or the state preceding it. We don't care whatever the word might be that is above it. We only care about the word that is just precedence of it. So to generate the word right next to it, we only see the ladies. And after we generate the word, now to generate the next, again we only see this preceding. We no longer care about the ladies to generate this word. So that is a markup chain. So this way we choose the word randomly again from that random word. See here, this will access the value of a dictionary randomly. Any of the word will be chosen, and we generate the next word, and we create a sentence. At the end of a sentence we give a period and we return the sentence. Let's say I will just run it, and I will just give a dictionary. And what is a dictionary here? Dictionary is this dictionary. This is a markup chain dictionary that we have created. Let us run this sentence, then you can see a sentence has been generated. Again, if I run this function one more time, next sentence will be generated. It's not dieting anymore. Since I hear the back, I would only flip out. Some of the sentence, angry refugees escaping a zombie, just, and a great dad, and everything was alike. And again we have next sentence, boom, a daily basis partially, because we are just such ecstasy with some body closes their whole food. See here, every time we run, we get the new sentence. So this way we can generate a sentence using markup chain. First of all, we create a dictionary which contains a word and which comes as a key, and the value will be the word that comes right next to it. We saw in this case, after what, there was an instance where we have the and we have can and should and so on. So this way we generate a text using markup chain. This is a simple procedure. We have so many complex module to use in order to generate a sentence. But if you want to just start with a machine learning and natural language processing, this is the first step to learn markup chain in order to generate a text. So that will be all in this section. I will see you on the next one.